this is a work in progress that I want to share. I have a conspiracy board of information because I recently encountered a slew of posts from creators that I love and who I would normally think of as very like critical thinkers, spreading misinformation about AI, particularly around AI power consumption and climate change, with claims that like asking ChatGPT a question is equivalent to like 1,000 Google searches or dumping out a cup of water. And I'm seeing these claims get spread uncritically all around. And so I wanted to track down the root of what that was, which I think I have found, and then also try and figure out like actual power use for AI. And the first hurdle is obviously that we need better terms to disambiguate different kinds of AI and different AI uses, because the power figures for one thing are not the same as the power figures for another. So if like asking ChatGPT a question is a completely different thing than generating an image. And it seems like most of the online vitriol is directed at image generation in particular, because that is a very visible kind of sloppy AI thing, video and images. And so I am putting out a call right here for people who have more experience with AI systems, hopefully at a larger scale. I want to talk about power consumption and get some better numbers. What I have been doing on my end, I picked up a kilowatt meter and I've got it on my desk, and I've been monitoring and taking measurements of my computer's power usage at various times. I've gotten power usage metrics for different AI models I've run locally, as well as other things just like playing video games, using Blender, and stuff like that. And I also have tracked down a web of sources to try and find where that initial claim came from. And what I have dug down to so far is the report, Electricity 2024 report from the International Energy Agency, which is a great agency that does a lot of important work. But there is one paragraph where they say search tools like Google could see a 10-fold increase of their electricity demand in the case of fully implementing AI in it. When comparing the average electricity demand of a typical Google search, 0.3 watt hours of electricity, to OpenAI's ChatGPT, 2.9 watt hours per request, and considering 9 billion searches daily, this would require almost 10 terawatts of additional electricity in a year. Their math checks out based on the claims they make, but that metric from OpenAI, that 2.9 watt hours per request, links to a website that is about, or it links to a paper called The Growing Energy Footprint of Artificial Intelligence by Alec de Vries, who is a PhD candidate at the Amsterdam School of Business and Economics, who got that figure from another website that was about like search engine optimization and power use. There's a rabbit trail that goes deeper and deeper down, and I haven't yet found the actual verifiable figures that number came from. But anyway, it ended up in Alex's paper here. The IEA reported on it, and then all of these other outlets went and changed the units around so that it would sound bigger and more scary, I was noticing. Like Nature.com decided to change watt hours to kilojoules, which is an indecipherable unit, but it's got kilo. Sounds very big.
Interesting.
And that kind of reporting, I think, just snowballed into these memes I'm seeing shared that are saying that AI is the biggest contributor to climate change. And at the same time, 2023 and 2024 were the hottest years on record by a bigger margin than usual. But the cause of that wasn't data center power consumption. It was actually a reduction in sulfur aerosol emissions from shipping that had been masking other warming effects of the climate. So actually cutting down on sulfur emissions from these big shipping vessels, which are toxic to humans and wildlife, has caused the global temperatures to rise. Couple that with a strong El Nino and a weird El Nino cycle. El Nino cycle. Nina. I'm talking too fast for my short tongue-tied tongue. The completely unrelated. We do still need to talk about CO2 emissions, which are the big concern with data center builds and stuff like that. And we can talk about the scale of these data centers getting bigger and bigger and more power hungry, because they are. And I have some great figures from that. I signed up for all these newsletters from datacenterdynamics.com.
Nice.
And I'll just throw out one of them, because I'm working on a bigger, well-presented project on this, but this is why I want extra help. This I thought was interesting. Legrand, which is a pretty embedded manufacturer of all sorts of various elements like power distribution, all this stuff you'd find in data centers. They put out an industry brief and they said, not that long ago, 50 megawatt data centers were enormous. Today, one prominent real estate company reports that its standard transaction size is 300 megawatts. And it's getting inquiries about building data centers up to 1 gigawatt. And we're all talking about gigawatt data centers now that cost between $6 to $8 million per megawatt. The servers that run these AI services, typically made by NVIDIA's DGX like H100 servers that weigh nearly 300 pounds and use up to 10 kilowatts per server. That's all real. The data centers are getting bigger, heavier, hotter, more dense, and more power hungry, but they are not the same. That is not the same thing as like generating an image on your computer, which I measured used about 360 watts for like 4 minutes, which was the equivalent of me playing BeamNG.drive for 4 minutes. All of these figures are really overblown. Getting good hard data about individual forms of energy consumption in different sectors of AI is difficult. OpenAI is not like great about talking about it. None of the big companies are. So if anyone who's listening to this has insight or information on this side of things, I want you to reach out and send an email to us, hello@eighthlayermedia.com. And in the subject line, if you could just put FAIK Power, FAIK Power, I'll search that up and look for any kind of input we can get. Or if you want to leave a voicemail at sayhi.chat/fake, because I want to put together a really good piece sort of demystifying AI power usage and climate change. Because as someone who I would describe myself as highly concerned about climate change, I want us to all be honest. And it feels like there's a lot of dishonesty because people have a distaste for AI, or because people are very pro AI and bullish on it, they want to ignore certain realities. And I think we need to split the uprights and just tell the truth. And I want some help with that.
Well, and it's interesting too, because when you start to look at the studies, when people are not precise with their words or their data, it gets really, really confusing, because people talk about like water use. But there's two types of water use, at least, right? There's withdrawal. So there's the water that's being used to cool things, and then there's consumption, which is water that never really enters the system again because it's just been used in different ways. But water that gets evaporated does get returned to the atmosphere, and that that gets turned back to good ecological use. But water that is totally gone is, of course, just totally gone. But that's not always disambiguated in the figures. And
it's also there's so much nuance to all of it, because a lot of the water use that people talk about is evaporative cooling, like you mentioned, where it goes back up into the atmosphere. That water doesn't always come back down in the same place as it was. And it's also taking like drinkable, potable water and evaporating it. And the way that the climate cycles and weather work, it doesn't always come back to the same place. So you can actually make arid areas more arid. And that is a concern. But evaporative cooling isn't, I believe it's not even like the main way that you cool things. And right now, especially, all of these big companies are moving to closed loop systems, which is like, anyone who's built a computer has seen like an all-in-one cooler. It's just got like liquid in it that never comes out. It's just all trapped in there, and it cycles around to a radiator, cools down, back to the hot place, gets hot, cycle to the radiator, cool down. They're moving to those kinds of things in the infrastructure. Obviously far more advanced, because at this scale, you're talking about these massive multi-thousands of pounds, hundreds of thousands of pounds of computers. The interconnects look more complicated. The way that plumbing works is more complicated. There's actually some speculation that the reason Microsoft paused construction on a big data center on the old Foxconn plant land is because they want to incorporate better, more sustainable cooling solutions. Because there's also an economic incentive to do that. The other ways to cool things are expensive. A closed loop system is more efficient in a lot of ways. And so there's just miles and miles and miles of nuance to cut through. And I want to make a simplified primer that is easy to understand. And that is my goal ultimately. And I wanted to put a call out to help for the people who listen to this show and might have more.
We should take all of the information that we get, all the different research studies, put them all into OpenAI's O1 model, and then just let it churn on that and destroy the world.
There we go. Yeah, have it optimize. It would be ironic, though, if it used up more power than it ended up saving.
Right. I mean, fun thing on that is, you know how OpenAI did this $200 a month plan for use for O1 and other things. they actually came out and said that they're losing money on that because people are using it way more than they anticipated.
I saw that, which I thought was interesting.
That's neither here nor there on the energy consumption bit, but it could be that people are using more powerful models when they don't necessarily need to. And one of the things that could be done to drop consumption of energy and everything else could be some pre-filtering on whatever query is there. So it directs it to the type of model that's going to be most efficient and most effective for that prompt that you put in.
Yeah, because it is totally true, generally speaking, that a bigger model is using more power per inference request.
Right.
Obviously, gains in efficiency in different, I don't know if architecture is the technically right term, but I think everyone knows what I mean. Like, all of that impacts energy use. But yeah, I think the idea of pre-filtering queries and sending them to, it kind of feels like the group of experts kind of vibe, except it's like group of interns or group of experts or whatever.
Yeah, or mixture of experts.
That's it.
I think is the.
I knew the acronym was MO,
term.
not GO. I couldn't remember.
Yeah, but anyway, if folks have studies that they've seen, articles that they've read, or want us to put into the pile of fodder that we're going to use for this, then send it our way.
Or even memes that you see in the wild about this, or claims that you're seeing. Like, half of this is about the discourse, and half of it is about the data, and those are both, I would say, equal halves, because I want to take the data and change the discourse if I can to be more honest. It just more realistic and grounded. It's really easy to get fired up by everything these days and lose nuance, and I don't want to contribute to that if I can avoid it. But there are genuine concerns around AI power consumption. We've gotten a voicemail or an email about it even too. So if you have concerns or questions, send those to help me guide my research.
We'll be our own little community notes where we're correcting ourselves on AI power consumption.
Absolutely.